of my background. I started my career in the United States Navy, rowed nuclear submarines. I actually met a kindred spirit here a little while ago, Australian sailor. Yeah, right, bubbleheads. Okay. I was an enlisted guy. I was termed a knuckle dragger. I operated the equipment in the sub. I didn't run the reactor, that kind of stuff. And knuckle dragger for me was a good description. Was evident when I did my first major maintenance disassembly. I took apart a lawnmower with a hammer and pliers as a kid. And I just continued that tradition. But on a submarine, it was a great place to learn about things that were going well. That's why I bring it up. The U.S. Navy, you might know, actually has about 500 operating years collectively of running on nuclear power with no nuclear accidents. So that's a pretty good record to draw from. I then went from the Navy into working with nuclear weapons, all aspects in the Department of Energy. Department of Energy has 17 national labs. They have about 50 scientific user facilities, and their funding last year was $31 billion, okay? So they do a lot of science. This is probably the best known science that they did, dubious distinction. But you'll notice that studying successful performance, number one statement up here, the only nuclear explosions were the ones that we intended. So during that period, I actually worked 30 years with the Department of Energy. I had various functions. The one that I did most of was research operations. I managed the operations at the National Laboratory in Idaho. It was an applied engineering lab. So it was not basic research. We actually did a lot of nuclear reactor type stuff. We did a number of national security projects. We had a lot of funding from the military. And it was at the Idaho National Lab that I first started learning about safety II. The real eye-opener for me was Sydney's book in 2002. The Field Guide to Understanding. And I and all of my colleagues got a hold of that book, and our minds just went like this. It was a great experience. It was a little later that we started learning about Erik's work, and again, our minds just opened up. It was a wonderful thing for us. But I wanted to tell you, the work I'm doing now is North Slope, up in Alaska. That's why I came from Alaska. These folks are doing things on a scale that I had never seen before. Any oil folks in here? Okay, I'll just tell you. Good, couple. So reservoir pressures in the 4,500 pound range up to, in some cases, 8,000 pound. Never dealt with pressures like that before in my work. Thousands of miles of pipelines, huge drilling rigs. This one here is the largest mobile drilling rig in the world. It weighs as much as 10 fully loaded 747s, and it can roll around on its own power, go over different locations to drill. It can drill 7 miles from its location with precision. And it doesn't just go down, it goes sideways. It can do spirals. It's just amazing. So you might start to understand why they've asked me to come up and talk to them about learning organization. Here's an example. This is not Conocco Philips. This is BP. Okay. Any environmental folks in here? All right. right? Well, it's 267,000 gallons of oil to the tundra. I'll just tell you, it goes over reportable limits. So here's my going in position to Conocco Philips. And I want to tell you, when I first got there, I was actually surprised that they had asked me to come up and help, because what I saw was an amazingly excellent operation, very productive. They don't spill oil to the tundra. They report 1 thimble of oil, okay? And they don't generally even spill those. They've got catches. They're one of the top performers in the oil business. But regardless, this is my going in position. Now, I'm not going to walk through every one of these. What I'm going to do is I'm going to tell you a story, all right? But I want to show you another headline. This is from a past assignment that I had with Los Alamos. So just give you the thumbnail, and I'm not going to tell you this story, but it gets you going. We had a eminent physicist decide on the anniversary of 9/11, notice the date here, that the best way for him to transport a high fidelity piece of a nuclear weapon, so it wasn't the actual one, it was a model, but he had managed to contaminate it with high explosive, which he didn't know, and carried it in his hand-carried baggage through TSA at Albuquerque Airport, and announced to the TSA agent that there was something in his bag that they probably want to look at. He ended up in jail, which is really traumatic for a PhD physicist, okay? But you might guess that when I tell you the story that I'm going to tell you now, there's a lot of angst over doing things with nuclear weapons, doing things with high energy accelerators. And so I'm going to tell you a story about doing something with both of them, all right? Post 9/11, the National Nuclear Security Agency decided that the biggest threat to the United States from nuclear weapons would be someone sneaking a nuclear weapon into the country in a cargo container. Because you might imagine, and I think you probably have a lot of shipping here that brings you materials, thousands and thousands and thousands of these coming through every day in all of our ports. And so they put out a request for a detection method for nuclear weapons coming in cargo containers. The Idaho National Lab, being a multidisciplinary applied engineering lab, really kind of got the nod. So the vice president of national security came to me in my role as operations manager and said, we know that we've never actually had nuclear weapons on the Idaho site, but we want to bring one and we want to shoot it with a linear accelerator and see if we can find the nuclear weapon without touching it. And we all said, what could possibly go wrong, right? So, but I want you to look now at my going in position and try and spot the things that I did to go at this from a safety two perspective, all right? So we actually found out that this individual had managed to do something similar to this at Los Alamos. But at Los Alamos, they don't have the expanse of room that we did in Idaho. So he wanted to come up so we could do it at a mile range. Now you're going to take a high energy linear accelerator, shoot it in open air, all the animals and people that could walk through at a nuclear weapon. We found out actually there are operating manuals for nuclear weapons. Okay, they're really big. But there's a design basis for a nuclear weapon, and one of the things that is intended is that you're not able to set it off unless you really want to. And so they've got a huge safety margin. It's basically considered an insensitive weapon. So we could actually kind of rule that out. All we had to do is accommodate the contingent of folks that tend to come with nuclear weapons. And I was talking to some of those national security type FBI people that come, right? But they've got all that figured out. So we just set that aside, and then we said, well, linear accelerator, it actually comes with a operating manual too, right? So we brought that out. And then we had to deal with the hardest part, and that's probably what I'm going to relate to you now. And that was all those regulators and operations safety folks and the people that at this time in the mid 2000s had learned that more is better in procedures, okay? And they wanted to see how all this fit together, and they were probably expecting in the vicinity of about 50 to 100 pages of procedures to describe how this was going to go. We ended up with 2 pages, right? And it was because not only did we have an operating manual for nuclear weapons, we had an operating manual for linear accelerator, but we had a staff of physicists and linear accelerator type people that had that base competence, and they were bringing that to the table. And what we needed to do was to define those things that were critical, going to Tony Mishar's work, if any of you ever heard of him, that absolutely must go well when we're doing this test. And we put those in the procedure. Everything else, we allowed for the individuals that were doing this work to work together and to have those interactions that you're hearing about, okay? And that interaction is what provided the safety, okay? So I'll tell you, we actually did shoot that nuclear weapon with a linear accelerator. It was a while. It took a long time to actually get folks through this and have them comfortable. And we actually found out that we couldn't bring the nuclear weapon to Idaho. It was just too hard. So we took it to a base in outside Washington, D.C., which is a much better place to inadvertently blow up a nuclear weapon. And we shot it there, all right? But we were able to detect this nuclear weapon at a mile, which is really cool, through a cargo container, and was highly shielded. So it was a success. And it actually exists now in many of the ports around the United States and around the world. So I hope you can see some of what my going in position now at Conocco Philips was. And I just wanted to show you, we're going to apply it here, okay? These guys, and I can't talk much about it because I actually don't have permission, but we've identified a place here that we can learn from success. These thousands of miles of pipeline are where this problem came from. Whoops. I think I'm going to fail here. The BP oil spill, the 200,000 plus gallons, every oil spill, every discharge of hazardous material in the Alaska tundra comes from a failure of the piping. And the piping fails because of corrosion. So there's an extensive corrosion monitoring process at Conocco Philips. And we found that they actually use a form of a linear accelerator to go out and irradiate their pipes. So it's wonderful. We can actually apply nuclear weapons and accelerators to Conocco Philips oil. So that's my overview, and I want to open it up for questions. How am I doing on time?
Someone's got to have at least a joke about those stories and how they come together.
Can you talk a little bit more about the MELD learning and incident investigation point, how that played out for you?
We had to change the conversation. We had to shift from finding or stopping the investigation when we found human error to using human error as the starting point and help people move past that. I'll give you an example. We did some drone research, again, for the military, and we had an individual struck in the bridge of the nose by one of the drone blades because he was doing some work and he didn't think it would start, and it did. And you just imagine, right, if it had hit here instead of here, And so it was pretty high profile. And it was actually our first implementation of the investigation and an understanding of local rationality from Sydney's work. And that was back in 2002. So, and it's just, you see my last step there is repeat. Todd's approach is lather, rinse, repeat. You just got to keep doing it and doing it and doing it. And that's been our experience, is that's what's working for us.
Hey, Dad. Sorry, we were joking earlier about the colour of T-shirts and choice of pants, right?
You got the memo.
I'm curious, with both of those examples you provided, and with the Navy as well, there's been large resources available to you to learn. How are you finding that with Conocco Philips? Have you still got that same level of resource available to do that learning? And is it scalable to smaller businesses?
Conocco Philips has a lot of focus on learning teams. They're very interested in the proactive learning team. We just did one recently where we have a whole aviation capability within Conocco Philips. We have our own airline, basically. And I had a request come to me to do a learning team on a navigational aid that was non-mandatory. And I suggested that we do something else. And so we ended up doing a learning team on what's working, because they had to write a management system for the new airfield they're building. And they were already flying, and we brought pilots, security, ground maintenance, and all those folks together and said, what's working? And basically defined the basis for our management system. And now you know who to talk to write it, right? Because they all were there. And then we used that to say, okay, that's working well, but what are you little less confident in? What could use a little polish? And they came up with the scheduling process of people, baggage, load balance, being done out of Anchorage for a North Slope operation. And it was clunky. And the pilots told us, we're thinking about bags and people while we're doing our approaches. And we said, okay, maybe we don't want you doing that, right? And very, very good focus there. For a small organization, you just make them a little easier. And our experience is that everybody is actually able to do them. The key is don't make them bureaucratic. Don't build extra things in, because learning outputs are really just supposed to go right back into your processes.
Jim, I'm curious around, you've got on your second dot point around establishing an operations pool, which I'm a huge advocate for. So can you talk a little bit about how you went about doing that, particularly in the context around a very high-risk environment?
Well, you know, I made some controversial statements to get folks a little bit open, like absent operations, actually there is no meaning to safety. Safety 1 plus safety 2 equals safety operations, those types of things. And the idea is that it was a lot easier for me to get a learning team together with aviation when I had the owner of the asset at Alpine, who's using aviation to fly people in and out so he can pump oil, tell me, I want to do proactive learning. I don't want to study a nav aid. And then I could go back to the aviation folks and say, you know, we think maybe we're going to redirect you, okay? But if I just did that on my own, they're like, well, who do you think you are, right? Well, I'm an emissary of operations. So.
Okay, let's give Jim a big clap before he sits down.